Hello good people, and welcome back to another math video. We are going to be talking about the area of a parallelogram, and this time we're going to be talking about finding the missing dimension. Alright, let's get started. First off, I want to do a little bit of equation review, and hopefully you remember this. And these are just some pretty simple equations, but they're going to be important for how we solve for a missing dimension in a parallelogram. So something like this, where we'd have 2x equals 8, and we know that when we have a number right up against a variable, that means that they're being multiplied. So this really means 2 times some number x, I don't know what it is, but 2 times that number is going to equal 8. And if you know your math facts, of course, that's going to be 2 times 4, but let's just go through how we would actually solve this. Since these are being multiplied by each other, we would do the opposite operation to solve, and that means we would divide. So I would divide this by 2, and we always divide by that coefficient out front, the 2. And these 2's will cancel, leaving me with just x on this side. But we have an equal sign right here, which means that whatever we do to one side, we need to do to the other side in order to keep things equal. So that means I need to divide the 8 by 2. And when I divide 8 by 2, I find that x is equal to 4. Alright, I'll do one more over here. Maybe I have 3y equals 15. So again, I'm going to do the opposite operation. This is 3 times y, so I have to divide by that coefficient, that 3. These 3's will cancel, leaving me with just y. But again, because this is an equal sign, I have to do the same thing on the opposite side. I have to divide 15 by 3, which will give me 5. So this is a little equation review because this is going to actually be quite important when we're solving the missing dimension in a parallelogram. Here's why. Here's a basic parallelogram, and in this parallelogram we see that the base is 8. The height is shown with a dashed line, but it's just given as h, and we're told that the area of this parallelogram is 32. And sorry, I'll put in 32 square units. So how do we figure out what the height actually is? Well, we know our area of a parallelogram formula, and that is the area of the parallelogram is equal to the base times the height. So let's begin to plug in what we know, or another word for that is to substitute. I know that the area is 32, so I'm going to substitute that 32 in for the area. I know that the base is 8. So I'm going to substitute that number in where my b is. I don't know h, so I'll just keep it there. So now I have this equation. 32 is equal to 8h. If you really don't like how that looks, it's fine to turn it around and just say 8h equals 32. It doesn't matter. And then this looks a lot like one of these, right? So let's kind of follow that same sort of plan. And I have 8 times h, and so I need to do the opposite operation. So I will divide by that coefficient. My 8's will cancel, leaving me with h on this side. Need to do the same thing over here. And 32 divided by 8 is 4. So the height of this parallelogram is 4 square units. Here's another example, only this time the height is given, but the base is not. So we see this parallelogram has a height of 10 and an area of 160 square units, and I do not know the base. So let's solve to figure out that missing dimension. I'm going to set up my area of a parallelogram formula, and that is a is equal to the base times the height. I know that a, that is right here, that is given as 160, so let me plug that in. 160 is equal to b times h. I don't know b, so I can keep b there. I do know h though, and that is 10. Now, this looks maybe a little bit funny to you because we have a variable in front. Luckily, we know the commutative property. Okay, and with the commutative property, the order in multiplying does not matter. So b times 10 is exactly the same as 10 times b. So feel free to rewrite all that so that it looks a little bit nicer to you if that's helpful. I'll do that right below it. So I'll switch the order here just like we did last time, and I'll say that 10b is equal to 160. Again, this does not matter at all. You don't have to reorder it, but we find that it kind of makes things maybe a little bit easier in your head. So I want to get b, I want that base. So right now it's being multiplied by 10, so I have to do the opposite operation, divide by 10, which will leave me with just b on this side. But it's an equation, so I have to do things equally, so I have to divide by 10 on this side. 160 divided by 10 is 16. So the base of this shape is 16 units. That's my base. All right, a quick little recap. The first is that remember when we do an equation that we are solving for the variable. We've done a lot of examples of that, so here we're just doing it with the area of a parallelogram. Secondly, remember our plan of following the formula, and that formula is area is equal to base times height, and then substitute in what you know. Depending on what the problem gives you, you might know the height, or maybe you know the base, and then you'll be given the area, and there's only going to be one of those that is missing, and you'll be able to solve for that. All right, hope that helps. You can watch it a few times if you need to. Have a great day, and we'll check in with you soon.